Hey, so today we're going to be solving equations that have two variables in it. And the main technique that we're going to see here is something that's called elimination. Now, substitution is certainly something that's out there, but it's just something that doesn't get widely used by a lot of students. So I think it's something to be aware of, but the main time is we're going to be using elimination because that's the most widely used method. And let's show you how it works. So if we've got something like 2y plus 7x equals negative 5. Now again, there's your two variables, your x and your y. Anytime we do solve these, whether it's elimination or substitution, typically we always see them stacked right on top of each other and with their like terms. And something like this. Okay, now, when it comes to elimination, the goal is exactly what it says. Eliminate, get rid of one of the variables. And we always like to use addition. And what's nice about this particular problem is right away, if I simply add the two of them together, right here, check this out. They're opposites. Bye-bye. All right, nighty-night. The x's are gone. And all I've got left is a one variable equation that we can end up solving for. And we get y equals 1. Now, we need to solve for x and y. So all we do is go back into one of the original equations. It doesn't matter which one we grab. Top one, bottom one there. All right. I'm going to use the top one. All right. So actually, I'll use the bottom one there. I don't know. It doesn't make a difference, like I said. But now I'll go after the bottom one. So it's 5 times 1. So we'll substitute the 1 in for my y. And what this allows me to do is allows me to solve for x now because I've only got one variable that's there. So 5 minus 7x equals 12. Let's subtract 5 from both sides. Negative 7x equals 7. Hey, yeah, divide both sides by negative 7, and we get ourselves x equals negative 1. So when we write out our answer, we write it out as an ordered pair. The x term comes first because we're writing out ordered pairs. So it's the solution of negative 1, 1. And the idea is if you would substitute negative 1 in for your x, substitute your 1 in for your y, then you would end up getting your negative 5. And if you substitute it in here as well, you would end up getting your 12. And you do. All right. Let's go into the second style of question. Now, that's your most straightforward one, and that's the one that we're happy to see. But we don't see that one very often. We typically see someone where we have some work to do. So let's go after someone like this. 3x and plus y equals 10, and negative 4x minus 2y equals 2. Okay, so if I just simply add these together, I'm not going to eliminate anyone at all. So what we're going to end up doing, negative 2y, what we're going to end up doing here is multiplying so that we can add. So one of the first things I'm looking for is always opposite signs. I like opposite signs because I need opposites to combine together in order to eliminate. And then I like it when the one number fits into the other one. Like I can't take 3. 3 times what's 4? Nothing here. But with this y, it is a 1y. Oh, if I multiply it by a 2, I'm going to be able to eliminate. So that's what we're going to do. We're going to multiply this entire top row by a 2. Watch what's going to happen. 2 times 3x, 6x. And is everyone. 2 times 1y, that's a 2y. And then 2 times 10 is a 20. So as long as we multiply it to everything, we're all good here. And if we just simply bring everyone below, now you're going to see that we're back to that original idea of, oh, there's my elimination if we add them together. So 2x equals 18, divide both sides by 2. Hey, we get x equals 9. And then we can slide on back over. I'm going to grab the top one simply because it's got doesn't have negatives, all right? And plus it's just a y, which is nice. 3 times 9 is 27. And then when I subtract my 27 over, the y is already by itself. And that makes our life a little bit easier. Y equals negative 17. And there we are. So our answer is the order pair 9, negative 17. So again, the nice thing about this is that it does get rid of the numbers, and we got it all taken care of as we kind of go through it. So we talked about checking your steps that's there, and it's a worthwhile thing to do here. So let's take a peek at it. I'm going to go right to this basic one of this 3, and there's my x, which is my 9, and then plus my 1y, so that would be a minus 17, and it should end up equaling 10. So 3 times 9 is 27. 27 minus 17, that does give me a 10 there, so I feel pretty good about that. And it's worthwhile to check the other one as well. Again, the idea is that we should be using some mental math here, and it should end up kind of speeding up things if there's ever any sort of uncertainty. There's a lot of computation that goes on here, so there's definitely a chance of something going wrong here. We want that to be a 2. And check this out. Negative 4 times 9 is a 36. 36 plus 17, is that a 2? Yeah, so what we wanted to show you here is like even if you just check one of them, like it could work for it like it did. And this is why that check. It depends on where your math ability is at. For someone like me, I'd like to, I don't know, there's the uncertainty. And what I'm going to do is I'm going to come back up into here. Maybe you saw it right away. Remember, we were adding 6 plus a negative 4. That gives me a 2. 20 plus 2, that should give, yeah. So that shouldn't have been an 18 there. That should have been a 22 that we were looking at. So 22 divided by x equals 11. So now when I plug it in, I can plug in my 11. There's my 33. I can subtract my 33 over. And then 10 minus 33, that's a negative 23. So now I got my official answer that's there of the order pair 11, comma, negative 23. So again, we did want to show you that it is a good thing to check. It shouldn't take that long, and the idea of probably about 30 seconds on a problem like this where there's a lot going on is definitely worth my time. All right, so that's it for today. We'll get into more of it tomorrow.